When looking at the periodic table, we see that silicon is part of group 14 and is situated between aluminum and phosphorus. That being the case, a silicon atom has 2 electrons in its first shell. It has 8 electrons in the second shell, but it has only 4 electrons in its outer shell. The outermost electrons are called valence electrons and are of utmost importance because all silicon atoms consist of not more than 4 valence electrons. However, all of the silicon atoms will form bonds by sharing electrons to achieve a full outer shell with 8 electrons, which makes them very stable. In order to disturb the stable state, doping atoms are purposely inserted into the silicon. When boron is combined with silicon, free holes will be created because boron has only 3 electrons in its outer level. With 5 valence electrons, phosphorus creates additional free electrons. And that's where the magic happens. A solar cell consists of 2 silicon panels sandwiched together. One layer is doped with N-type dopants, the other is doped with P-type dopants. To allow an electrical flow of electrons, a front and a back contact are installed to the layers. Glass is installed on top of it to protect the layers and the electrical contacts from damage. Now it's time to take a closer look at the area between both layers. In the N-doped semiconductor, there is an axis of electrons. In the P-doped semiconductor, we observe positively charged electron holes. The electrons in one layer will find their corresponding free holes in the other layer. Consequently, an internal electrical field builds up at this transition that does not permit electrons and holes to jump into the other layer. However, if photons hit the silicon layers, electron-hole pairs will be created. If this happens in the electrical field, electrons are moved to the N-doped layer and holes are moved to the P-doped layer. The system will fall into a state of imbalance because of an excess of electrons in the N-doped layer. The corresponding holes can be found in the P-doped layer. It goes without saying that these free electrons and free holes try to combine. However, the electrical field does not allow such a condition. But if you connect the top layer to the other layer, for example by using a cable,